Hello everyone. This video we're going to be looking at similar polygons and triangles. In the video below the one you're watching right now is actually going to go into a little more details on the correct definition of a polygon. Um, but really all it is a closed shape with straight sides, okay? And exactly two sides will meet at a vertex, okay? Um, so basically, if you have something with a curved surface on it, it's not a polygon. If the lines aren't joined, for example, if there's no way to calculate a perimeter, that wouldn't be a polygon either. All sides have to be joined up and meeting at a vertex, okay, and be composed of straight lines. So check out that video and on page 271 in your Math Makes Sense 9 workbook for a little more info on that. Okay, so right now this video is going to be focusing on similarities. Okay, so what are similar polygons? Well, two polygons are similar if the corresponding angles are congruent and the lengths of the corresponding sides are proportional. Okay, so what we did last week when we did enlargements and reductions, we would say that those polygons are similar. Okay, and similar polygons have the same shape, but not necessarily the same size. All right, so when two polygons are similar, matching angles are equal and the matching sides are proportional. And we'll explore a little bit about what that means. So again, here's an example. Um, in order to be congruent, two figures must have the same size and the same shape. So in this picture, these objects, which kind of look like stop signs, would be congruent. And these are a definition of similar because, as you see, they're the same shape, but not necessarily the same size, and they likely contain the same proportions. So, a similar polygon. What we're looking at here is polygon ABCD, and is it similar to EF, G, and H? Okay, so how we express this is it's almost like if we took the smaller one and laid it over the top here. How would these sides match up? So B and A, or line AB, would be similar to line EF, just as B and C, the top one, I'll call it the shorter one on the top, I'm referring to this as the bottom, would be similar to line segment FG. Okay, and you can see as we're writing it here, AB will be over EF. Okay, and you can flip these over and say EF over AB. It doesn't make a difference. Okay, so another example would be CD. Okay, which line over here corresponds to that? Well, it will be GH. So in your expression down here, you would write CD over GH. Okay, and this type of expression is going to help us solve unknown variables. Okay, and here we go. We'll look at solving unknown variables, which is going to be the focus on your quiz this week. So we can see that line BA we do have a measurement for. It's 2. Okay, we have FE, which is 4. So over here we have 6 for BC, and we have an unknown variable here for line FG. So how do we express that? Well, just as we did in the previous one, except we plug in the numbers um, in place of the line segment indicators. So instead of writing AB, we write 2. Okay, so 2 is similar to FE, which is 4. So we say 2 over 4. Okay, is equal to BC, which is 6, over line X, FG. Okay, so we've set up our equation here. So once we get to this point, now we can cross multiply. Okay, so what I'm going to do first here is try and solve for my variable. So I'm going to multiply my variable. I'm going to say 2 times x, and I'm going to say is equal to 6 times 4. So when I do that, 2 times x gives me 2x, and 6 times 4 gives me 24. Now I need to solve for x. So as you guys remember from your previous units, when you have a coefficient, which is a number attached to a variable, which is a letter, the only way to split up this number and a letter is to divide. We're going to divide by whatever number the coefficient is. So in this case, the coefficient is 2. So we're just going to divide by 2 on this side. And whatever we do to one side, of course, we have to do to the other side. So we're dividing by 2, and 24 divided by 2 will give us 12. Okay? So we can see that the proportion here, we know that they're similar because 2 and 4. Well, 4 is double 2, right? 2 times 2 is 4. Okay? In order for this to be similar, any other line here that I multiply by 2 should give me a similar or the same proportion uh, on the diagram on the right hand side. So if I said 2 times 2 gives me 4, I must say 6 times 2 gives me 12. Okay? If this bottom one was 7, then this bottom one over here would be 14 because I would just multiply it by 2. Okay? Um, when you're looking at triangles, triangles of course are polygons because they have straight lines and they're all connected through vertices. Okay? They're closed off. So all angles are the same. So, for example, angle A here would be equal to angle E over here. As B, if that's 90 degrees, then F will be 90 degrees, and so on. Okay? Just as the sides would be, like in the previous example. So AB, similar to EF, just a different size, right? So if all of these match up, okay, then we can say that triangle ABC is similar to EFG. So you probably can't see it on the bottom of your screen there, but that's a G. Okay, so when you have a triangle, we're just doing exactly the same way as we did in the first one. So we're going to line up our proportions here. We've got an unknown variable here, x, which corresponds to the 6. So I could put x over 6, okay, or 6 over x, doesn't make a difference. So once I line those two up, 6 over x, I can say 7 over 35, okay? And if you notice, you have to keep things aligned with each other. And what I mean by that is if I can't say x over 7, okay, because this line is not similar to this line, okay? This x line is similar to this 6 line, okay? So I can't mix and match. So I can't say line RS is similar to VW, okay? So that's not the case. That's not how the triangles are set up in this example. So 6 over x, I've lined those two up. So now my VW line, which is 7, would be similar to my TS line, which is 35. So I would have to say 7 over 35, okay? So again, once I get to this point, all I do is say 7 times x and then 6 times 35, okay? So the math on that would be 7x equals 35 times 6, which is 210. So I'm left with 7x equals 210. So I want to break up the 7 and x, so I divide by 7 to do that. And of course I divide my 210 by 7 and I would get 30. All right. Moving on, I'll just do another example here quick with triangles. So as we can see, 12 and x correspond with each other here. These are similar. So x over 12, and I would say 30 over 40. Okay, and again, keep it similar in that I said x over 12. So I said the triangle on the right was on top here. Okay, so that means I can't say 40 over 30. I have to keep everything the same. Okay, so if I chose the one on the right, x over the left one here, 12, which correspond with each other, I have to choose 30 over 40. Okay, keep it consistent. And again, the math on this, x times 40 equals 12 times 30. That'll be 360 divided by 40, and you'll end up with 9. Okay. I'm not going to bother with this example, although it is in your PowerPoint link back on your main page. This is the last example I will do. So we've got a quadrilateral here, which of course is a polygon. So it says quadrilateral JKLM. So JKLM is similar to PQRS. Okay. So what we realize here is if we take this quadrilateral and we rotate it a little bit to the right, we'll see that this Z on the bottom corresponds to this 10 over here. Okay, and then the 6 line QP here will be similar to line KJ, which is 15. So we can go ahead and set up our equation here. So we've chose the 15 here first. So I'd say 15 over 6 equals, and you got to go back to the left again first, 10 over Z. Okay? And again, at this point, I would simply cross multiply, get 15Z there and 60. And I need to divide by 15 here to cancel out this Z. So I would divide by 15 here. And of course, I'd get Z to equal to 4. Okay? If you want to decide if they're similar and set up in the same proportions, once you know a couple values, you can do that as well. Because I can say, um, for example, 15 divided by 6. So if you went to your calculator and did that, you would see you would get 2.5. Okay? So if I did 10 over 4, if they are similar, I should get 2.5 because 2.5 is my scale factor then. Okay? That means they're proportionate. So I would say 10 divided by 4 gives me 2.5. And I'm just doing it on my calculator here now, and of course it does work out. Um, so now we know that the scale factor would be 2.5 in this case, and that they are similar. And that's it for this week, guys. Please come see me if you need extra help or clarification. Definitely doing the pages in your workbook is going to help you a lot this week. It's a lot to cover, and I didn't want the video to go on too long, but I'm more than willing to help you on site. Okay, thanks.